Hi, everybody. Obviously, I am not 100% here today. I'm out on a field trip. So here is a little video guiding you through today. So for your warm-up, I'd like you to, as quickly as you can, go get your lab journals and answer these warm-up questions. So we've got a box of mass M attached to a spring of constant K, and we're going to compress it a distance D. If I release the box, the question is, first of all, how much force is the spring applying right at that first moment? And to what height h does it make it up the hill? So go ahead and pause this video for a minute while you go grab your lab journals and answer the warm-up question. All right, so today we're going to be working on a lab, this bungee jumping lab. So it's all about springs and conservation of energy. As a quick reminder, we do have 2 new UT quests about potential energy and conservation of energy that are due next Friday. So do get started on those. So let's talk about our warm-up. We've had a little bit of time to work on that. How much force is the spring applying? Well, we know that springs apply a force equal to K times how far they're stretched or compressed. So KD would be the force there. If I want to know the height that makes it up the hill, I start with 1/2 kx squared worth of potential energy, and I end with mgh worth of potential energy, worth of gravitational potential energy. So if I solve for h, I get kd squared over 2 mg. In fact, today is going to be all about that trade-off of energy. So just a quick reminder on springs. Spring forces. The force required to compress or stretch a spring is given to us by Kx. The minus sign just tells us the direction. K is called the spring constant, and it's measured in newtons per meter. You're going to actually measure that for a spring today. Please note that that x in here is not the length of the spring. It's just how much the length changes. So springs have some natural length L that they want to be. So if you're trying to measure the spring constant, make sure that you're only measuring how far the spring stretches or compresses. You probably also want to know the natural length of the spring, but just be careful that the x is the change in length of the spring. And we've already found that for that same change in length x, that we get a potential energy of 1/2 kx squared. So let's talk about a little bit about our lab. What we're going to do is we're going to start off here with a mass M. That's going to be your jumper. It's going to be attached to a spring. That spring is going to have some natural unstretched length L, as well as a big piece of string. And we're going to start at some total height h. You can in fact see the orange bucket with the platform right in the front of the class. As this thing falls, at some point, the string is going to be fully taut. And once the string is fully taut, the spring is going to start to extend and slow down our mass. And at somewhere at the very bottom, our mass is going to be at rest. Our string will have a length big L. Our spring will have started at its natural length, little curly L, and have extended some amount delta X. And our goal is to figure out how much string do we need such that our thing just barely doesn't hit the ground. We want it to come a couple centimeters off the ground. Obviously, if your string is way too short, your thing's not going to fall very far at all. If your string is way too long, it's going to slam into the ground without the spring ever stretching. So there's 2 parts to this lab. The first thing we need to do is we need to figure out our spring. So let's go get some materials. So pause the video for a moment. And send an emissary to go get from the sidebar a spring, a lead weight, that's going to be your jumper, a spring stand, and there's plenty of other things, rulers, spring scales, and other weights as needed. So I'll wait a moment while you go get that stuff. All right. There's 2 parts to this lab, like I said. The first part is to find the K value for our spring. I am not going to tell you how to do this. I'm going to let you design an experiment. So we're going to take about 5 or 10 minutes here for you to have a little discussion with your groups about how you're going to find K. Hints, I would look at this equation and figure out what do I need to measure, what do I need to know in order to calculate K? Is there a way for me to do that? And a double hint, just remember, we always have to do multiple trials. We also always have to vary things. So when you're doing multiple trials, make sure you're, for instance, not applying the same force every time. Vary your force, take multiple measurements at different values in order to try and calculate K. So take a couple minutes and discuss how you're going to do that. Come to some kind of consensus in your group. There's going to be some additional information on the lab sheet. All right, hopefully you've had 5 or 10 minutes to discuss that. Once you've found the K, and that's going to be your first task, is to find the K value, you're going to set up conservation of energy to figure out L. If you measure how tall the platform is, you'll know how much potential energy it starts with. Here at the bottom, we don't have any kinetic energy left. Once again, we only have potential energy. So if you kind of equate the two energies, right, what you can do is you can actually figure out how far your spring stretches. If you know how far your spring stretches, and you know the rested length of your spring, and you know the total height, well, it turns out you can do a little bit of arithmetic and figure out how big your string needs to be, how long your string needs to be for the thing to just barely touch the ground. And my advice here would be calculate what L needs to be to touch the ground, and then just shave a couple centimeters off to give yourself a margin of error. Once you've got all that calculation, you found your K, you figured out what the length of your string is, go ahead and set it up and then drop the thing off the platform. Please take a video if anybody's got slow motion so that we can see how far you come off the ground, because I'm interested. Did you come 2 centimeters, 3 centimeters, 8 centimeters off the ground? Did you hit the ground? What happened? If you have any other questions about the procedures, please refer to the lab sheet. And I look forward to hearing how it goes on Friday. So again, part 1, find the K for your spring. Part 2, figure out how long your string should be. Just as a note, in 4th period yesterday, we were able to get everybody to find K, and most of the groups were able to actually finish their calculations and test. So I would expect that most of you are going to be able to get through the most of this lab today. All right, good luck and have a great day.